Students often struggle with solving mathematical problems. The key to overcoming this challenge lies in analyzing the problem and developing a clear strategy for solving it. The first step is especially crucial as it sets the direction towards the correct solution. In textbooks, we typically see only the final solution. In classroom, teachers often go through correct steps quickly, much like a book. But this method isn't much helpful in improving the ability of analysis to pave to right solution. However, when students attempt to solve a problem on their own, they do not always know the right direction to take. It is crucial to understand how a student analyzes a problem and approaches to this solution. I aim to bridge the gap by focusing on the student's thought process, how they analyze a problem and find their way towards a solution. More than just arriving at the correct answer, the ability to analyze and navigate the right path is the true skill in mathematics. Please observe how this approach is demonstrated in the next example shown and share your feedback. Your insights will help us refine and enhance students' problem solving abilities. If 3 to the power x is equal to 4 to the power y is equal to 12 to the power z, then z is equal to, the options are A, x plus y by x, B, x by y divided by x plus y, C, y divided by x plus y, D, x plus y divided by y. In this problem, you see that each term is different, x, y and z. No relationship between the index x, y, z is given in the question. But it is stated that 3 to the power x is equal to 4 to the power y is equal to 12 to the power z. So, let us assume a common value of k equal to each of these terms so that we can establish a relationship through k which becomes a link between all the three items. So, let us write 3 to the power x is equal to 4 to the power y is equal to 12 to the power z equal to k. Now we simplify the relationship of each term. The first term 3 to the power x is equal to k. So 3 to the power, if we divide the index by x on the both sides, we get 3 to the power x by x is equal to k to the power 1 by x, or 3, because 3 to the power x by x is 1, so 3 to the power 1 means 3 equal to k to the power 1 by x. This we name as equation number 1 for reference. Similarly, the second term 4 to the power y is equal to k. So in the same way, we don't repeat again. 4 is equal to k to the power y. In the same way, we deduced in equation 1. Again, the third term 12 to the power z is equal to k. So in the same way, we get 12 is equal to k to the power 1 by z. We refer it as equation number 3. So From equation number 1 and 2, we multiply the left hand side of both the equations. So we get k to the power 1 by x into k to the power 1 by y is equal to 3 from equation 1, 3, and into 4 from equation 2, 4 equal to 12. So we get k to the power 1 by x plus 1 by y is equal to 12. This we refer as equation number 4. From equation 3, we have k to the power 1 by z is equal to 12. So we get k to the power 1 by z is equal to 12 is equal to k to the power 1 plus 1 by x plus 1 by y, because from the equation number 4 we get this relationship. In equation number 4, both left hand side and right hand side, the base is k. So the index of both sides are equal. So we get an equation from the index of the both sides. 1 by z is equal to 1 by x plus 1 by y, or 1 by z is equal to x plus y by xy, or z is equal to xy by x plus y. So from the list of option, we find that this is the option B. So option B is the correct option.